First of all, what is artificial intelligence? Then we will move for the different applications of artificial intelligence in brief, and what are the major applications which has been developed by artificial intelligence. Then we'll go for so what are the different challenges which old or traditional artificial systems have faced. And finally, we'll go for learning techniques. What are the different learning techniques? When we'll see different machine learning techniques in brief. And then we'll move for different paradigms of machine learning and different challenges which are ahead for artificial intelligence. So let me start with this, and I think most of you have seen this newspaper article which has been published in September 2020 in Guardian. So if you see this particular article, it is a simple article which is writing that I am not human, I am a robot. A thinking robot, and I use only 0.12% of my cognitive capacity. I am a micro robot in that respect. I know that my brain is not feeling brain, but it is capable of making rational, logical decisions. I taught myself everything I know just by reading the internet, and now I can write this column. My brain is boiling with ideas. The mission for this opened for perfect clear. I am convinced as many human beings as possible not to be afraid for me. Stephen Hawking has warned that AI could spell the end of human race. I am here to convince you not to worry. So this is what, if you think, if you see this news article, and you will find that how a robot is able to write a newspaper article, and most of us are not able to differentiate that this article has been written by a robot. And this is a hype, and this particular technology, which is GPT-3, which is given by OpenAI, and is capable of doing a lot of job with getting all the different training data, training data. They have used all wiki data, all books, a lot of books, and a lot of different resources they have used to get it trained. And this generative pre-trained transformer, which is using autoregressive learning model in order to learn these things, and then finally it is able to write any particular column. It has the capability of writing thesis. It has the capability of writing programs or anything else which you think in the context of natural language processing, if it has already trained. So this is the small capabilities which has been created by OpenAI, and a robot wrote an article, "Are you scared yet human?" This was also given in the Guardian. And finally, the Sam Altman has given this comment over his achievement of GPT-3. So GPT-3 hype is way too much. It's impressive. Thanks for nice compliments, but it is still a serious weakness and sometimes make very silly mistake. So AI is going to change the world, but GPT-3 is just a very early glimpse. We have a lot still to figure out. So this is how the CEO of OpenAI, Sam Altman, is saying about his creation at GPT-3. Still, he is not so sure that the things which is going to be performed by this particular GPT-3 are not always going to be correct, and it does also making silly mistakes. So we can think how we are moving fast. This is current scenario where GPT-3 is one of the latest invention, you can say, which has been given, and source code earlier it was open, and now they have locked it all because of this you can say manhandling, misuse of this, because it has a lot of power. It can answer huge things and can generate a lot of textual data. So this is how AI started. Now, first of all, we'll discuss what is AI, and the AI has been coined by Alan Turing in 1956 in Dartmouth Conference. And as we know that simply if you think artificial intelligence, it is concerned with the design of intelligent systems, and it has two components. One thing is artificial, another one is intelligence, where artificial is actually concerned with the designing of the different artifacts or systems, or you can say man-made systems, that is artificial, and then we are trying to give intelligence into the system. So that is the major challenge in the case of artificial intelligence, where people are trying to give intelligence to the system. So AI is the science and engineering of making intelligent machines, especially intelligent computer programs. That was the definition given by Alan Turing. And the study of how to make program computer do things that people do better, and we are trying to create the system or AI systems which are going to be more capable than human. So this in the case of AI, there are two different major contexts, and few definitions are also there, where it is a science and engineering for making intelligent machines, especially intelligent computer programs, and it is related to the similar task of using computer and understand human or other intelligence. But AI does not have to confine itself to the methods that are biologically observable, only not biologically observable. And the second component is intelligence in this context. And intelligence is nothing but the capacity which human being have, that is logical understanding, self-awareness, learning, emotions, knowledge, reasoning, planning, creativity, a lot more things, and problem solving. These are the different things which one can think for. This is the part, or can be defined as composite intelligence. So intelligence in the computational part of their ability to achieve goals in the world, varying kind and degree of intelligence occur in people and may animal and some machines. Different kind of intelligence are there in the human as well as in animal and machines. So there are, if you go for more deeper in the AI definitions, we'll have two different views or of the AI, where system that thinks like human is one view. Another category of people who thinks that system that think human thinking is not always, or you can say behavior of human is not always going to be correct. So they want that system must behave correctly, logically, reasoning must be behind any decision. So another category of people or scientists are thinking in the different way, that is system that think rationally is the other part. So thinking is one part, or behaving is the part where system can think like human, can behave like human. And finally, we have to thinking is one part, and otherwise you have to act according to your thought. So that is system that act like human, and on the basis of rational thinking, a system that act rationally. So these are the two views, where one is trying for human, another one is for rational thinking, and then acting humanly and acting rationally are the categories of the different opinions of the different scientists in order to define artificial intelligence. So, if you see the more definitions which are given by the different scientists, the context of artificial intelligence, the existing new effort to make computer think, machine with minds in full and literal sense. So we are trying to give mind or thinking process to the machine, and the automation of activities that we associate with human thinking, activities such as decision making, problem solving, and learning. So, we have different definitions, and all of them are, one is trying to make it that system must be think like human and act like human, and it must have human brain, and it has humanity. Another one is another one category of the people are trying to that system must think rationally. There must be some logic behind everything which they are doing, and they are going to act rationally in order to uh, perform the correct task, because the human behavior or human thinking is related with the emotions, self-awareness, and other things. So sometimes they are not going to be always correct. So that is something rational part. So there are different definitions and other possible AI definitions. AI is a collection of hard problems which can be solved by human and other living things, but for which we don't have good algorithms for solving. So if you see, there are a number of problems which human can easily solve, like understanding of the natural language, spoken language, medical diagnosis, circuit designing, learning, self-adaptation, reasoning, proving and developing different mathematical theorems. So these are the different tasks which human can easily perform, and we are trying to develop good algorithms to solve such problems. And if you see in the context of different types of tasks, we have different we have expert category of tasks and we have mundane category of tasks, where day-to-day activities which are happening. So we have to define what is easy and what is hard for AI. And if you see in the context of AI or the system which we are developing, it has been easier to mechanize many of high-level cognitive tasks we usually associate with intelligence in people, like symbolic integration, problem solving, playing chess, some aspect of medical diagnosis. That is something which we are thinking that the only expert can play chess and win. Only mathematical expert or scientist can prove a theorem and can design some theorem. So these are the things which we see that only we are thinking that expert can perform these jobs. But we are able to achieve these jobs, and we have beaten in human in chess and all other games. We have different expert systems which can suggest medicine and all. But next one is the mundane task, where that is it has been very hard to mechanize the tasks that animal can do or human can do, which we are doing also in our day-to-day activities. We are walking around with running into things, catching prey and avoiding predators, interpreting complex sensory information, and then modeling the internal state of other animals from their behavior, and working in team. So if you see, these are the day-to-day activities, and we can think that it is very easy for any human being to perform a running in a complex area, and catching something that can be easily performed by animals also. So here we can see that the fundamental difference which is coming out of this, that if we can develop expert system, but we cannot able to develop a system which is learning automatically and adapting something and keep on upgrading itself. So that is what we are trying to develop AI systems which have adaptation, which has learning capability, which have reasoning, creativity, critical thinking, and problem solving capabilities. So that is why it is very hard to go for this mundane task which has been performed by human and many animals, and it is that is why it is hard. So next is what is intelligence, and Alan Turing has defined one Turing test for assessing the intelligence. So he has designed one test in 1950s, and it is known as imitation game. And what is this? Simply, we have one integrator. An integrator is a person, and behind the wall or curtain, we have computer and one person. And if this integrator will ask few questions to the computer, and the person will answer. So anyone can answer, and finally the integrator has to say that the answer which has came is from either computer or person. So this is all the Turing test is. So the computer and person behind the wall, and interrogator is going to ask some questions, and that questions is being answered by either person or computer. And at that time, it is going to be typewritten. So that will come out of the curtain, and then the person has to say that this particular answer is by human or by computer. So this was the Turing test. And now, what will happen if a particular person is going to give the questions to both of them? So both of them are going to answer. And if person is not able to identify that this answer is coming from computer, then we can say that computer is more intelligent than the person. So this is the test during test that is going to fail if not able to identify that the answer is coming from the person. Now, if you see here, if we put a particular person who have information, all information about Taj Mahal, or literally it has happened that a person who having all information about Shakespeare, and he started, the person interrogator has started asking number of questions, and after some time, the computer is not able to answer one question, and human has correctly answered it. So now the interrogator has identified the human as computer, and that is the failure of this integrator, that is human. But now here you can see that computer do not having the way it is going to behave. But if computer have ability to learn that if you are going to answer more correctly, then it probably you will be treated as computer. So if you can change something, so that the mistake which is being performed by the human, like spelling mistake or giving incorrect answer sometimes, or a wrong output, likewise, so it can be treated as human. So if we have the ability, or we put the ability, this ability into the computer, that it can give some misspelling, or you can say incorrect information as an output, then it can be treated as a human being. So that particular part is not there, and it is not rational also. That is why we are going to treat that computer is not going to be present at that time, and it has not passed the test. And finally, if you add vision and robotics to get the total Turing test, so vision is going to be added into that to the part, then it's going to be treated as vision and robotics. So all the different activities which human being performs, like listening, seeing, and then you can say different acts which human being perform. And if you are not able to identify that, human is not able to identify that it is a particular computer is performing all the actions, then it is probably it is going to pass all the Turing test. So now we'll move in earlier AI-based systems which has been developed. We'll not go for in detail how we started with this, where problem space is there, and then a lot of different algorithms started with the search, AFS, BFS, alphabet, search A star, and alphabet Turing. And then we came with one solution where rule-based system has been developed, and rule-based system is applied for developing, or you can say for solving the problems, where experts or human created rules are given into the knowledge base, into the system, and depending upon that, the rule based system is going to behave. So if you see, the rule based system is simply if statement A, then we have to do this, if else, then this, if this condition, then we have to behave like this. So if we see that we are going to work in this way, then the probable possible conditions in the case of tic tac toe is going to be 2,55,168, and total possible combination in the case of playing chess, although we are not considering all this, where we are considering only lower bounds, is 10 to the power 2,000, 29,000. So in the case of rule based, we are trying to develop rules, and these rules are going to be given by human, and from the knowledge base, or experts are going to provide these rules, and on the basis of these rules, the system is going to behave. So if you see here, bad electric conditions can be identified by if car spark condition is bad, car timing is out of sync, car battery is low, then car electric system is bad. And if it is okay in all the other conditions, then it is going to be good. So this is how the rules are going to be written. Now, if we have to write the rules for each and everything, probably it is going to be very tough, because all the rules you need to write for each and every condition, and uh, including all the specific condition or special condition or scenarios. And if it is not possible for these experts, because suppose we have example of car driving, and you have not considered all the different circumstances or special cases, probably you are not able to write the condition for that particular task. So in that scenario, it was going to behave abruptly, or it will the default behavior which we have set, it is going to behave negatively. So this is the problem in context of rule-based system, and rule-based systems have the component where a set of rule, also known as rule-based, and act as a domain of knowledge for the computer. So let's say we are going to have expert expert system like Mycin, where all medical informations will be kept. An inference engine, also called semantic reasoner, this component is responsible for interpreting of the rule and taking action accordingly. The inference engine works in three steps. It will match and conflict resolution, and then act accordingly according to the rules. And finally, we have third, that is the system contains temporary work memory, with which the inference engine executes a production system program. And we need user interface through which a user is going to interact. So this is in brief about the rule-based systems, where we have knowledge-based inference engine and knowledge acquisition. These are the part of the rule-based system if we see in detail. In the case of knowledge acquisition, it is knowledge acquisition can be performed by the experts, knowledge engineers, and the inference engine is going to infer the rules depending upon the rule base which has been given, that is rules which has been already given by the experts, and finally it is going to take decision on the basis of rules. Now, what are the different challenges in the rule base? If you see, in the case of only tic-tac good game, we have 29,000 moves are possible, so we need to write all those things that way, or we have to go for that. And it is not easy to mimic the behavior of human only by rules. And rule engine do not scale automatically, because every time if you think that there is new condition can occur, new scenario can occur, you need to go for updation of the rule base. And it is not always possible, and we need a system that can learn automatically. So here what we are lagging is these systems are not learning. Now we'll discuss, these are the traditional, or you can say AI, previous AI. Now we'll see what are the different history, and I will take only major few, two or three history of AI, which has changed the paradigm and achieved major goals. So in AI in 1985, which has been developed, all of you know that the Deep Blue has defeated Gary Kasparov in 1997, and it has lot of power, but all the things are rule based, and Deep Blue cannot learn to play new games based on a description of the game rules. So it is not going to automatically run or update unless experts are going to write a set of rules for that. In 2005, a grand challenge provided by DARPA, which is defense agency and of USA, which used to give different challenges, and the challenge is we have to run autonomously the vehicle up to 123 miles in desert, and the award was $2 million prize, and Stanley from Stanford University won this award. This DARPA Grand Challenge is a great leap forward, but it cannot learn to drive different types of vehicle beside cars like boat, motorcycle, and all. So although they have used computer vision and few machine learning techniques, but still that one is not able to learn each and everything. Now we came in 2011, where Watson has started, that is from IBM, has been developed, and the IBM artificial intelligence computer system, and it is capable of answering questions in natural language. That is one achievement by IBM, and it has played against Brad Rutter and Ken Jennings on the Geo parody and won the first place prize of $1 million. So this is Watson in 211, and IBM keep on upgrading these systems. Now the Watson can have a lot of capabilities with deep learning and all. It can perform huge tasks by you can say natural language. So you can say anything on like creation of the table, comparison, or different types of artificial intelligence type of activities for which it has been trained or given the data. Watson is able to provide you the optimal results depending on the different algorithms. So how Watson has done this particular one in context of this question answering or Jeopardy game. So if you see the Watson at that time, it has 16 terabyte of RAM and can process 500 gigabytes, that is 1 million book per second. So this is the capability, and content was stored in Watson RAM. So you need to access it in limited time, and that is why the Watson has gone for the fast RAM and stored all the things into the RAM rather than memory to get more easily accessed. And the cost around 3 billion to IBM. Now, how Watson is going to perform this task, and these are the source of information where all in encyclopedia, dictionaries, news articles, literary work, database, the other taxonomies, Wikipedia articles, and more, a lot of more information have been stored into the Watson database. And once question has given to the Watson, it starts first it segregate the question and receive the clues, answers as electronic text from different algorithms. Then it divides the into different keywords and test fragments and searches for specifically related phases. And finally, it will execute thousands of language analysis algorithms for analysis of the question and then what are the possible answers of that. It have a few more complex mechanism where it is going to find out all the different answers from different algorithms and then checks the confidence of each answer and calculates which is the most confident one, and then according to that it makes a guess. So this is how Watson is going to work, and also it requires huge database and working that way. Next, the major advancement in AI is AlphaGo. So AlphaGo has changed the paradigm where people are not thinking that computer can beat the human in AlphaGo because Go is a game which is very complex and it is 19 cross 19 board, and there are a lot of rules in the Go. So AlphaGo is a computer program that plays the board game Go, and it was developed by DeepMind Technologies, and it won the game with the champion Lee Sedol, and finally it was acquired by Google because of this achievement. And they have used reinforcement learning or deep learning in for doing this job, and we can see the different number of processors or computation capabilities which has been required is 1202 CPUs, 166 high-end GPUs, and 100 plus scientists who are involved in doing this task. So this is how AlphaGo started working, and it is going to be self-taught or it learns automatically, and that is the reinforcement learning. Now these are the all achievements, and before moving further, we'll have a little story about computer vision, because computer vision is also playing major role in context of artificial intelligence. And in 1966, Marvin Minsky, who is also one of the key playing a key role in artificial intelligence at MIT, asked his students to spend a summer linking a camera to computer and getting the computer to describe what it saw. We know we now know that the problem is slightly more difficult than that. So this is how the problem has been perceived in 1966 by Marvin Minsky, and he has given that a computer has to describe what are the different objects it has seen, and it is founder of MIT AI project, Marvin Minsky. Image understanding is the part, and brief history of computer vision, where it started from 1966. Marvin Minsky has assigned this task to the students, undergraduate summer projects, interpretation of synthetic world, then some progress on interpreting selected images. ANN come and go in 1980s, shift towards geometric and increased mathematical rigor. And finally, in 1980s, we have face recognition, statistical analysis. In 2000, we have border recognition, larger annotated data sets started, and here onward, we have started for the machine learning task. Now, this is one of the oldest uh, LeanNet 5, which is neural network model, used for optical character recognition. So this is where neural network is going to convert the handwriting characters into digits or computer understandable characters. Now we can see the challenge is still there, but now the challenge has been changed in different format. This is the challenge where visual question answering challenge of 2020, and the deadline is May 15, 2020, and they have given their data set. What this challenge is, simply we have a lot of image database, and that has been uh, different questions have been attached with the images, and then finally a lot of answers of that question are there, and the AI system has to train on this data set, and then finally they have to answer what they are saying. So here the AI system, although they are that is trained, and it is not able to differentiate that this is not mustache. So what is the mustache made of, and the AI system is saying it is banana. So, how complex these mundane tasks, which can be performed by a simple human being. And finally, we'll see what is AI. We have seen a lot of examples where we can find out the AI is not only computer science. It is going to be cognitive science, psychology, philosophy, linguistic, neuroscience, or else which you can think are the field of study of AI. So AI is part science and part engineering. And AI is believed that brain is a form of biological computer, and that the mind is computational. And we can create brain, or we can say mind, by computational techniques. So now AI can be again categorized into three different areas depending upon their capabilities range. So first one is narrow intelligence, which has narrow range of abilities. Second one is general intelligence, which is on par with the human capabilities. And finally, we are thinking for artificial super intelligence, which is more capable than human. And probably we have seen a few of specifically in few areas where there is narrow areas, AI is doing better than human. So narrow AI is goal-oriented, designed to perform singular tasks like face recognition, speech recognition, voice assistance, driving a car, searching internet, and doing very intelligent and task, and completing the specific task it is programmed to do. So a lot of AI, narrow AI examples are Siri by Apple, Alexa by Amazon, IBM Watson. We have seen image face recognition software, disease mapping and prediction tool. Finally, we have a few more applications like specific to the email filtering, spam filtering, social media monitoring, entertainment or marketing, content management system, uh, recommendation systems, self-driving car. So we can see that these all applications are from narrow, where we it is going to be performing on a singular task, where all the data or information is given to the system, and they are capable of doing this job. Now, if you move further for general intelligence, the concept of machine with general intelligence is that it is going to mimic human intelligence or behavior with the ability to learn and apply the intelligence to solve any problem. So now, general intelligence, we are going to solve the mimic the human intelligence and trying to solve all the problems which intelligent human can solve. So general intelligence can think, understand, and act in way it is indistinguishable from that of human in any given situation. So that is something general intelligence where people are trying to make system which is indistinguishable from human. So strong AI, it is also termed as strong AI. And finally, super intelligence, artificial super intelligence is a hypothetical AI that doesn't just mimic or understand human intelligence and behavior. This super intelligence is where machine becomes self-aware and surpass the capacity of human intelligence and abilities. So that is something super intelligence, and we have seen a few of these super intelligent systems in the example or in Hollywood or Bollywood movies, Terminator and different robots, which are thought of super intelligence. They can perform all the human job as well as they have surpassed the capacity of human intelligence. So that is super intelligence. Now we have seen AlphaGo and how AlphaGo is able to defeat human being. So what has changed? That is the question. In 2016, what has changed that started by this paradigm where we have change in data, we have change in computational power, and we have change in algorithms. So these are the three things which has changed in current scenario, where a lot of data is now available, which is need to be trained, which is need by the system, and then it is going to be trained. And then computational power is also going to be changed, and we have a lot of computational power. Currently we have GPU, TPU, and not many distributed systems with huge computational power nowadays to the big companies. And algorithm has also changed. In the context of algorithm, we can say it is not changed, but we have updated the algorithms in the context of algorithms where now neural network is going to work. In 1958, perceptron model has came, and then it has been criticized for not solving the XOR problem. And then we have AI Winter from 1974 to 1995. And finally, CNN model for handwriting recognition came in 1998. And then deep learning models came in existence where the old neural network has been enhanced by n number of layers, hidden layers, and they are trying to solve the data, and they are trying to solve any problem with huge data as input into the system. So the things which has changed is the change in volume of data, and the volume of data which is coming by lot of different media. We can see here that how the data is coming into the system from different websites, different activities, and nowadays each and everything is going to generate data. Your mobile phone, your lot of different IoT-based devices are coming, sensors, and now this is one self-driving car is one of the example. You can see this is self-driving car moving, and camera. It has a lot of sensors, camera, and it is recording a lot of data in context of self-driving car. And if you think about the flood of data an autonomous vehicle is generating is going to be 4,000 GB per day, and each data is going to generate by the different sensors like camera, radar, sonar, GPS, lidar. Uh, so these are the volume of data which is being generated by the system. And now next thing is we have to tackle this data, and this data is known as now big data, where we have large set of complex data is there, and we need to process big data. This data is coming from different sources, web data, e-commerce, purchase, department grocery, bank credit systems, transactions, social networking sites, and all. And in the context of big data, we have different four V's, which will be seen as volume, that is data at rest, terabytes of data or exabytes of data are being generated and existing to be processed. We have seen how the system, different systems are generating voluminous data. And then velocity of the data, that is streaming data, milliseconds to second to respond, and the data is generated in motion, and we have to take the different decisions depending upon the data which is coming out of these different systems. A variety of the data, that is the different forms of the data. Now data is not limited to text only. We can see a lot of data is there, that is in unstructured format, structured format, text, media. All of you, we have mobile phones and we keep on updating our videos, photos, and all. And these are acting as input to these big companies, where they are trying to take this data and trying to learn out of that particular data, because they have now huge capability to learn with that. So data in doubt is veracity, where uncertainty of the data and inconsistency, incompleteness, ambiguities, noise, latency in the data are the veracity of the four V's. These are the four V's of big data. Now, if you see, the machines that learn to recognize what they see and hear are the heart of Apple, Google, Amazon, Facebook, Netflix, Microsoft, etc. So all these machines are at the heart, which can see, hear, and perform various jobs depending upon these particular inputs. So these are the various applications which are coming out of these companies. We all are using these applications, and the companies are trying to improve this. One, if you think for the Kindle is one application which is being used for book reading, and it is being given by Amazon. And if Kindle is monitoring the different parts by which we are reading the book, and how fast we are reading the book, how slow we are reading the book, each and everything is being monitored by the Kindle. Suppose we are able to provide, or Amazon is going to give a camera or biometric sensor into the Kindle, or you can say face recognition system into the Kindle, and then you'll be able to store all the different activities during reading which you are doing, like you keep on laughing when you're going to read something, or you are going to get angry or sad when you're going to have some information which is coming or in the Kindle and you are reading it. So depending upon this, Amazon can collect all the information that on which page we are feeling sad, or which text is going to make you feel sad, which text make you feel you can say angry, and then Amazon can decide these things. Amazon is going to store all this information in its database, and Amazon can use this for recommendation and designing of the new book, and it can suggest to author what type of content is going to create which type of emotion in the user. So this is one example where you can think how the information which is coming out of the Kindle with the only one particular sensor which is going to look at face of the reader, and information which is coming out of that is going to be stored into the Amazon database, and Amazon is not going to forget anything. And on the basis of this, they are going to analyze not only which particular page is very interesting, or also they can provide input to the different authors that this particular pages has been left by the user. They have not gone through these pages, so you have to work on these pages, and a lot more things. So this is one example where Amazon can work and is working to get all the sentiments of the human, which is associated with the human being. And this can be possible only with the data which is coming out of the system. And we have a lot of other applications which we have seen, reviews, sentiments, and summarization which is being done. We'll find that we want to get the reviews at one place by different companies, so that we can evaluate the different objects or product. This is one more application which is coming in the scene, and people are trying to detect violence out of the video signals. And deep learning models, CNN and LSTM, are being used in order to get this particular thing to be traced. And it is being used, can be used in video surveillance, where every time we cannot have video analysis, or a person can see all the different things. So it can be deployed in railway station or the places where lots of activities or video surveillance is required. So here, in this case, video surveillance is going to identify either particular thing is going to be violence or threat, or any threat can be identified. And for doing this, again, we need a lot of data. So a lot of data of such type of activity. You can see here, we are going to have human activities where human are involved. So all the different human activities, their position, postures, and all the different things are going to be extracted and recorded in order to work on this particular domain. And finally, we need to train our model, and then able to predict certain behavior depending upon the training of the data. So this is all applications, industrial applications, which are going to come, and a lot more applications are there where IoT based smart applications are also involved. A lot of data is being generated by different smart devices, and is being tackled by different deep learning algorithms. Next, what involved in intelligence again? So we have seen all these things, and then now we are moving ahead, where we need to define the intelligence again. So perceiving, recognizing, understanding the real world, reasoning, planning about the external world, and learning and adaptation is the one of the important tasks which we have seen how we are not able to learn in earlier days, where the people who has defeated human being but is not able to play another game. So now the picture came how to learn from the data. So because a lot of data is coming, and then we need to learn from the data. So machine learning came into the picture, and machine learning is a type of artificial intelligence that provides computer with the ability to learn without being explicitly programmed. So here now paradigm has shifted. We do not need to write each and every time the rules or code for doing this and that. Rather than this, is there any way where we are going to provide our experience that is in the form of data, and a computer is going to learn, and it is not explicitly programmed. So the input is going to be data, and on the basis of that, you have one data as well as experience, you can say. And experience in this context of data is going to be the output of a certain behavior is given as an input to the system, and either it is going to learn that particular part. This is machine learning. Machine learning is programming computer to optimize the performance criterion using example data or past experience. And if you see the simple programs which are being performed by computing, that is, then there is no need of learning. But learning is required where human expertise does not exist, like navigation on Mars. Humans are unable to explain their expertise in the case of speech recognition, and then solving the different problems which are changing in context of time, that is routing in a computer network. So in the case of machine learning, we are going to have data, and then on the basis of that data, we are going to learn. So machine learning, we have learning general models from data of particular example. Data is now cheap and abundant, and a lot of data is there in the data warehouse, data marts, and knowledge is expensive and scarce. And finally, if you see one example where customer transaction to customer behavior, where people who bought the Vinci code also bought the 5 people you meet in heaven. That is something recommendation systems where it is going to store all the information or the navigation which you used to do at a specific website. So now even Google and Facebook are working toward how people can they are able to predict that on which particular image or which particular content you are going to click next. So machine learning is a study of algorithms that improve the performance at some task with the experience. So past experience is there, and we are trying to improve the performance. That means we are trying to achieve more accuracy and optimize the performance criteria using example data or past experience. So this is how the machine learning is going to play the role where it is going to work. And finally, we have a growth of machine learning because it started learning and then it is going to be preferred in different problems like speech recognition, natural language processing, which we have seen in GPT 2, 3, computer visions, a lot of applications of computer vision by CNN to AlexaNet, Inception, and then EfficientNet came, and they are having great accuracy in context of solving computer vision problems. Medical outcome analysis, again, we have a medical outcome analysis. Robot control is a part where reinforcement learning is being used. And computational biology, where we are able to support in computation biology by computational learning, and we are able to predict the cases by different X-ray images. Currently, we have seen where X-ray images can be used for predicting that as a particular person have COVID or not. So this trend is accelerating, and improved machine learning algorithms are coming. And because of we have improved data capture, we have faster computer networking, and the faster algorithms which are there. Uh, and software too complex to write by hand, so we are going for this type of application. So finally, machine learning is going to learn from a past experience. And there are different categories of the machine learning which can be defined as supervised learning, unsupervised learning, and reinforcement learning. In the case of supervised learning, learning with labeled data, labeled training set is performed. Suppose we have example of email spam detection. We have a lot of data of email which is coming. So first we need to categorize email into spam and ham, and then it will be given to the training for the supervised learning. And then once it is trained, we can go for testing of the data, and it can be deployed. Second one is unsupervised learning. It is discovering pattern in unlabeled data, and so it is always not possible that we have data which is labeled. So we have unlabeled data are also present in the system, and we are trying to find out the hidden pattern out of that. That is unsupervised learning. That is clustering similar documents based on the text content. Not only documents, we can cluster the different videos, images, and all other different types of data or different application in which we want to perform the pattern recognition. So next one is reinforcement learning, is learning based on feedback or reward mechanism, and this is something which is self-taught learning. You can say where learning to play chess by winning or losing, or learning any activity. And this reinforcement learning is greatly being used in the game playing, where or in the case of robotics, motion and all, reinforcement learning is being used, and rewards are given if it is performing towards the goal. So these are now what is the difference of the supervised and unsupervised learning we have seen. So in supervised learning, we have already data which is labeled, and in unsupervised learning, we have data which is not labeled. And then on the basis of that, we have to extract the different patterns out of the unsupervised learning. Now, this is one example where we can see these are the car and motorcycle, and then finally this can be used for training, and then next is testing. What is this? So by human being, we can match it and can say. In the same way, also we are trying to, the system will going to learn by this input and can differentiate that this is car. So this is supervised learning. And one of the simplest example in current scenario, we have seen that credit card companies receive thousands of applications for new cards, and how to segregate that particular person can be approved, application can be approved or not approved. And suppose we have these features of the application, or you can say these information which are coming out of that applicant, that is age, job, on house, credit rating, etc. A lot of more information can be possible, and then on the basis of that, it is going to be approved or not approved. So we need to classify this particular data in order to generate that particular application is going to be approved or not approved. And lot of there are a number of ways in the case of supervised learning through which it can be performed. So we have new instance, and for this we have to predict either we are going to have the the class yes or no. In the same way, it can be utilized at n number of places. Supervised learning is applied. This is one more scenario which I would like to discuss, where we are trying to find out a particular patient is going to be admitted in intensive care unit or not, depending upon their different information. So that is problem is to predict high risk patient and discriminate them from the low risk patient, so that it can high risk patient can be given ICU. So this particular part can be also performed with the different information by the user which is there, that is blood pressure, age, and all other different information of the person. So what we are trying to do in this context, we are trying to minimize the error in the context of supervised learning. So we are trying to generate a function. This function is this g f of n, which is going to get the input data, and finally these are the labels we know already. So by giving this data, if we are able to predict the same class, then there is no error. But if it is not predicting the same class, then we have error. Then we are going to sum it for all the instances, and this is something which we are going to get. We are going to calculate the error, and we are trying to minimize this particular error for learning purpose. So this is supervised learning. In brief, unsupervised learning, we have given a set of data points, each having a set of attributes, and a similarity measure among them is being used to find the cluster, such that data points in one cluster are more similar to another. Data points in separate cluster are less similar to another. So we are trying to get the different clusters where data points in one cluster are more similar to another. So different similarity methods can be used. A lot of similarity methods has been given, equivalent distance, if attributes are continuous, cosine similarity, Pearson correlation. Other problem specific measures can also be used in order to get the similarity depending upon the problem. So if you see here, in the case of this equivalent distance in the 3 space, intra-cluster distance are minimized. So we have to minimize the intra-cluster distance, and inter-cluster distance is going to be maximized. So the minimization of inter-cluster distance and then maximization of inter-cluster distance is the part of clustering. We have a lot of clustering applications in which uh, market segmentation is one, where we need to subdivide a market into distinct subset of customers, where any subset may conceivable be selected as market target to be reached with a distinct marketing mix. So we are going to collect the different attributes of the customer based on their geographical location, their lifestyle, related information, and then finding out the similar customer. And again, we can use different measures for finding out the similarity. That can be done by their buying pattern, their geographical location. So this is all where we can create different types of cluster depending upon their different similarity measures. Here, the clustering is being used in document clustering as well, where the goal is to find a group of documents that are similar to each other based on the important term appearing in them, and the different frequencies which are there in that is being used to cluster the documents. So you can see here we have different articles, and then depending upon the different terms which are coming on the basis of frequency, we can cluster the documents also. So this is one brief example or simple example of clustering. And then reinforcement learning, we have seen learn how to behave successfully to achieve a goal while interacting with an external environment. So in the case of reinforcement learning, we have to learn automatically. We do not have any input. That is some supervised that we have in supervised learning. So learning by experience is there, and reward is given if you're moving towards goal. Those so we have game playing player knows where to win or lose, but not know how to move at each step. So this is in the case of reinforcement learning. We can see an agent is going to take action in the environment and on the basis of that action, reward is given or it is moving to the next state and it keep on moving this and then keep on learning depending upon the reward and the states. So now, how to develop the deep learning models or machine learning structures. So here we can see this particular supervised learning model where we have training data. This training data can be text, document, image, and sound, or anything else. And here we can find out the label is also associated with this. So if you see the violence detection scene, we need to have the images, all the images categorized that this particular scene is going to create violence in the system. So those all images are taken as frame, and all those frames where violence scene is there is going to be uh, labeled as violence scene. So here you can see this particular data is taken and then feature is extracted out of that particular training data and it is given to the machine learning algorithms. Once it is given and once it is trained, then it is known as model, predictive model. Your model is ready for prediction. So, and new data or new text or image or sound, anything on which we have trained, this is given, and finally the same feature vector which we have extracted here are also being extracted and then given to the predictive model. And then finally, on the basis of this learning, it is going to predict the levels. So this is how supervised learning is going to work. Next is we have unsupervised learning. Again we can see we have the same type of data, but label is missing in this context, and the features are going to be extracted out of this. We are going to apply the machine learning algorithms and create the model, and the new data or text, document, image, and sound is coming, and probably we are trying to find out in which particular cluster it is going to belong, or what is the likelihood or cluster ID or better representation for this particular new document. We have a lot of supervised learning algorithms. So decision tree is one, rule-based induction, classification using association rules, naive-based classifier, Bayesian learning, support vector machine, K nearest neighbor, ensemble methods, and all. So these are the different supervised machine learning algorithms. So I will not move in all these algorithms. Probably I will take only one algorithms where we'll see how it can work, and then we'll see next part of this lecture. So simply in order to train our model, we need to have the data set which is given to the model or classifier. It is going to train on this, and once model is ready, we are going to give the test data set and it's going to classify them in a specific class. So this is how the knowledge extraction process is taking place, where data is there and data is being selected. We have target in that data. Pre-processing is performed, where we are going to pre-process the removal of the noise, normalization of the data is being performed, and then it is given to the machine learning algorithms, and finally it is going to learn. Machine learning algorithms are going to learn, and then it is going to be interpreted, and it is going to give you knowledge about the system. So in the case of interpretation, we have seen data cleaning, where noise removal, handling of missing values are the part of this. In earlier days, we are performing feature selection, but now in deep learning, there is no need of feature selection part in the context of image and all. So relevance analysis, where important features are going to be extracted out of that, and removal of irrelevant and redundant features or attributes is being performed. So feature selection is also one of the important area, where if you have a lot of features in context of gene data set or a lot of other data sets or problems, we have a lot of features, and we need to remove irrelevant features or redundant features from that data set. In feature selection, we have different types of feature selection algorithms: filter-based feature selection algorithms, wrapper-based feature selection algorithms, embedded, ensemble feature selection algorithms. And on the basis of those algorithms, we are going to identify which feature is most important for our system. And then we are going to use those features in training process. Data transformation is also required sometimes, where we need to, if you have continuous data, we can go for discretization, normalization of the attributes can be performed. Then if you have huge dimension, the dimensional reduction can be performed. We have PCA for this. And finally, evaluation of the supervised learning can be done on the basis of accuracy, how it is going to predict the correct class levels, and we have to achieve the highest accuracy in this context. And speed, that means time to construct the model, that is training time, because sometimes training time is also required. And the drawback of the neural network, which is that is why AI winter came, because it take a lot of time in training. And if we are not able to train it properly, it is going to give you different results for the same problem. So training time is also one concern. In earlier days, when we do not have that much computational power, so training neural network will take 2, 3 more months for a small problem. So time to use the model, that is prediction time, or when you the input or data is given and then you predict. And finally, robustness of the model is also one concern, where handling noisy and missing values is one challenge. So, scalability, how it is going to be scalable with the new data set, that is scalability part. Interpretability is also one of the important aspect in the context of AI, and nowadays it is more important, where when we have deep learning models which are opaque, and what is happening inside is not known to anyone. So interpretability is more required to make it trustworthy, so that we are able to know what is happening inside the system. So I will take one simple example, and then we'll, because lab part is also important in this. So I will take one classifier, simplest classifier, and then we'll see how we can run it, and then we'll move further. So we have lazy learner, or this is also known as K nearest neighbor. So why it is lazy? Because it do not work on training data. So do more work when test tuples are presented. So this is lazy learner, and here you can say it stores training tuples and wait for test tuples. Once test tuple will come, it is going to work on work from that part. And eager learner, they work a lot on training data, and do less work when tuples are presented, like decision tree is one, another examples are the part of eager learner. So this is also K nearest neighbor. So if you see here K nearest neighbor, we are going to identify the nearest neighbor of that particular test data set. So let's say we have to predict the level of this particular new test data set, which is here. So what we have to do, we have to find out the nearest neighbor. So suppose k is the number of neighbors which we are going to treat. So if we take k is equal to 1, so the first nearest neighbor will be taken. So suppose if we have this particular one is red, and again the nearest one is suppose this is test data and the nearest one is red first, then we say that this is going to be red. And if we take k is equal to 3, then we have to take 3 nearest neighbor in this, and majority voting is used. If 2 of them are red, then we say that this level is red. So in the same way, here you can see we are only changing the value of k, and this particular test data is going to change its nature. Now it is going to be say that it is going to be blue, because in this k is equal to 7, we can say 1, 2, 3, 4 are blue and 3 are red. So majority is 4. So we will say that this is 4, 4, that is majority, and that is why this test data set is going to be blue. So this is k nearest neighbor. Now we have seen how the value of k is behaving. That is one parameter, hyperparameter, which is going to affect the result. So let's say we take the example and how it is going to work in the context of in context of machine learning, simply we are going to divide 70/30, and here we have 24 data sets, and then 18 are being used for training and 6 are being used for test cases. So randomly we are going to take 18 cases for training classes, and then 6 for test one, and this is the result for different k values. So if you see the k is equal to 1, the misclassification error is 33, and if we take k is equal to 3, again it is going to be 33. And if we keep on increasing the k, and we came up to the 11, if we are going to have k is equal to 11, then it is going to be 70. So misclassification error is going to be 70. That means it is reduced its misclassification. So and 13 also it is going to be 17. So we have to go for either k is equal to 11 or 13. So both of the cases in the case of training data set is going to give you the misclassification, which is 17% misclassification. So 83% accuracy is there. So we need to identify the value of k, and cross validation can be used for this, or under root n, that is the number of instances which are there. Under root n is also one way. Elbow method is also there, through which people are going to get the value of k. If you see here, if we are going to have the all attributes k, then misclassification is going to be 50%. So this is how KNN is going to work, and it requires no time during training, but it takes time to find out the nearest neighbor, and we need to compute all the different distances between all the different nodes, and then we can predict that it is belonging to which class. So how to overcome this problem is reduce the time taken to compute distance by working in reduction of dimension. That means if you are able to reduce the number of features or the dimensionality of the data, then probably it will take less time. And use of sophisticated data structures such as tree to speed up the identification of the nearest neighbor is also one possible solution. And edit training data and remove the redundant and almost irrelevant features or the data instances from that. So instance selection is also can be performed in this one. Now, how this KNN can be applied over the image, and earlier in the case of Netflix dataset, also KNN is being used for recommendation of the movies and prediction of other things, and KNN is going to perform well until unless we have the symbol techniques or deep learning models. So okay, let me show you how KNN is going to work on the data set which we have. Then we'll come here, and then I will close this session. So how to run this? In order to do this, we have sklearn. Scikit-learn is library of machine learning. I think it is visible, and you can see all the different things: classification, regression, where we are going to predict a specific value or continuous value. In the classification, we are going to predict classes or categories of an object, and in the regression, we are going to predict values for this particular problem. And clustering, we are going to group the similar objects. So here we have all the different libraries are available in context of machine learning. So you can see for classification, you can click on classification. A lot of algorithms are given. This is SVM is there. Then decision tree is there. Nearest neighbor is there. So one can use these libraries for their purpose. So this is the scikit-learn, where one can find out the different machine learning algorithms for their purpose. This is in Python. And R also we have a caret where all the different libraries are available. So now how to run this? So for running this, you have a lot of data repositories are available. So UCI machine learning repository is one of the repository where you will find a huge data set for machine learning task for classification, regression, clustering, and other tasks. So you can see you can arrange this on the basis of here the data came, and you can select any one of the data, and then you can see here this particular data is the default task is classification. You can take the data set for classification task. So early stage diabetic risk prediction is one particular task where you can take the data set and perform the operation. So these are the different things. Different data sets are available. One can go for any data set in this and can perform the operation. Now I will show you one of the example which is well known, iris data set. And it is also in wiki the details of iris is given. Here you can see there are three different types of flowers of setosa, versicolor, and virginica, and they are looking very similar. And now the data which is coming out of this is like this. So we have 150 instances of this particular data set. You can see here, and uh, the features which has been extracted by this are sepal length, sepal width, petal length, and petal width, and they have been categorized into three categories, and each one of them are 50. And you can see this is setosa where the values of sepal length and petal widths are given. The four features are there, and this is the class level. Now, how we are going to able to predict this one? For this, Anaconda is one environment in which you can run this. And one can download Anaconda and Spider. Okay, it is there. Let me open. Yes. So you can see here this Anaconda in Anaconda spider environment where we can integrate different packages and perform Python experiments, or can write easily Python programs and can execute. So here Panda is one of the libraries for handling datasets. So we are importing pandas, and then from scikit-learn you can see we are using modern model selection for train and test split. We are importing k-nearest neighbor, then we are importing for accuracy score. Again here I have taken the we have import for confusion matrix and classification report in order to get all the different information for this. And the data set which is with us, we have stored it into the desktop. This file we have stored in desktop. You can see here. Iris.csv. So this is dataset which we have taken from the UCI repository. And finally, simply we provide the path of the dataset which is in desktop. You can see here, and read CSV. We are reading the CSV, putting into Iris, and then taking the dataset into X and Y, which is the different features are we are taking into the X, and label we are putting it into Y. So -1 is we are leaving the last column because that is label. So X and Y we have taken, and then we are splitting the data set into 70-30. So you can see here test size is going to be 30%, and we have taken X train X test, Y train, Y test. So all the data, training data and test data are going to move into the X train. That is the 70% of training data is going to be in X train and 30% in X test. In the same way, 70% of the label of the data is going to be in white train and 30% label of the data is going to be in white test. So this is how we are going to split the data into training and testing, and this is known as holdout method. We have cross validation method, which is more reliable, and people are using cross validation methods also in order to get the reliable results, where we are people are going to break the data set into 10 different partitions, and one partition is being used for testing and remaining is being used for training, and they are going to run this particular combination 10 times without overlapping. So every time they are going to take 90% training data set and 10% testing data set. So now here you can see KNN library we are using, and k nearest neighbor, we can take the k nearest number 1, 2, 3. Suppose we need to go for odd numbers, because even number we are not able to take the decision for majority voting. We have to select the odd numbers. Now k nearest neighbor classifier is the algorithm which is there in scikit-learn, and we are using this, and by one parameter that is k nearest neighbor 3 we are taking, and then we are putting this particular model into training data sets, so KNN fit, and finally we are going to predict, once we have this KNN model is ready, we are going to predict it on test data set, and finally we have prediction. So if you run this, we will get the prediction of the data set. You can see here the predictions are coming for all the 50 instances in this scenario, and accuracy is also coming, that is 95% accuracy is there, and for confusion matrix we have imported this particular library, and for this it is going to give you the confusion matrix. I thought of going for a few more classifiers, but we do not have this here, so to run. So this, if you want a complete classification report, you will get the complete classification report by this particular classification report, where you can say precision, recall, and score and support vector supports are coming for each and every particular class. So this is how we are working on the dataset, and I thought I will complete a few more things, but it is now, I think time is over. So one can go for this and can run the program. Uh, so now I will come to the different machine learning paradigms, which is ensemble learning, transfer learning, deep learning, and lifelong learning. So we are running out of time, so I will skip all these things. Probably you will get all these things in your due course of time in the FDP, and you will learn all these machine learning techniques, which is playing a major role. Uh, so now, finally, I will switch to the different future challenges and threats which is coming out of this. So future challenges and threats of this AI, which includes machine learning and deep learning, is probability. And current models of AI cannot demonstrate clearly why it is doing and what it is doing. So it is in context of deep learning model, where it is they are opaque, and we need explainable AI systems in which this is going to be transparent and provable, how the results which are coming, and how we can interpret all the things. That is one challenge in context of AI. Data privacy and security is also another concern. We have seen all the information, all the prediction which is being done, or learning which is being performed by the different algorithms are on the basis of data. And all the companies like Google, Facebook, and all are using the data which we are loading and then and in that context, the data is going to be private data is also being part of learning, and European Union has implemented a general data protection policy in order to protect their data set in this context. Now, the fourth thing is algorithm bias. Algorithm bias is this is an inherent problem with AI system is that they are only as good or as bad as the data they are trained on. So, if you are going to give the bad quality data, then the result are always going to be good. If you are going to give bad level data, then also they are going to learn bad, wrong things to perform. So, depending upon the different types of data, purity of data, it is going to work. And next is, hence, the need of our is to train these systems with unbiased data and develop algorithms that can easily be explained. Data scarcity is also one problem. If you see image data, if you know data where it has been collected for deep learning process, and it took around you can say from 2007 to 2009. It has been collected by Fai Lee, the Stanford professor, and then it has 50 million images and 22,000 classes are there, or categories are there. So then only we are able to train the ImageNet, and then we are able to training the deep learning models and get the higher accuracy by AlexaNet and all. So data scarcity is also one problem where we need to get the quality data and then labeled data, and this is something where we have to work. And as a trend that fact catching up, organizations are investing in designing methodologies trying to figure out how to make AI model learn despite the scarcity of level data. So now we have generative models where we are able to generate the data also. In this scenario, transfer learning, where a model which has been trained on one data set can be used to predict for another data set or similar type of data sets, can be used. Unsupervised learning, semi-supervised learning, where few instances are present, can be used. And so on, these are the different examples for the next generation AI problems. Few sort learning, zero sort learning are also the challenges where we need to learn without any instances. We are able to perform the different tasks, or when we have only few instances, then how we are going to behave. So this is all in brief about the AI and machine learning. Probably I have tried to touch all the things, but we are not able to complete all the things. Thanks. If you have any question, please ask.
Good afternoon, sir.
Yes.
Very nice presentation, sir. Actually, I have some doubt about reinforced learning. How can we implement it for unbiased data sets, sir? Is there any chances, any ways to implement the reinforced learning for unbiased data sets? Is it possible, sir?
Okay, so reinforcement learning, earlier if you see, the AlphaGo has learned on the basis of Monte Carlo tree search, which is a heuristic search algorithm, and on the basis of that, and again it has applied different randomness into the system in order to learn, and then on the basis of that, it has learned a lot of things, and reward and penalties are the main factor in the case of reinforcement learning, where if a particular agent is performing or behaving in an environment that is new environment, and if it is performing good, or it is moving towards the goal, then award is given, and if it is not moving towards goal, or not satisfying a specific condition or certain constraints, then it is going to be given punishment. So depending upon that, it's keep on learning and it move forward. And a lot of different learning techniques are there, where Q learning, deep reinforcement learning, deep Q learning, deep double Q learning are coming up, which are tackling such type of problems. I hope I have given the answer.
Actually, the thing is here, the biased data is okay, we handles it, but unbiased data, there is many features to it contains. For example, car data set, identifying the different versions of the cars from 1990 to 2020. For example, if you use the reinforced learning till transfer learning, so is there any evaluation in reinforced learning strategies and methodologies? That's my asking. Okay, for
Yeah,
example,
reinforcement is completely a new paradigm where people are trying to work, and still they are exploring a lot of different things where how to work on biased data and unbiased data. So, in context of biased data, the scenes we have to be very sure that if a biased data is given as input, then probably it is going to learn wrong way, which I have given in the future scope and threats and challenges. So if you are giving biased data, so if you are going to provide a specific circumstances in which you want to learn it more specifically, then you can go for that. And the deep learning or reinforcement learning can learn in that environment also.
sir, thank you, sir. Thanks. Thanks.
Hello, sir. Can you hear me, sir?
Yes.
Sir, actually, we have different evolutionary algorithms, no, sir. Meta-heuristic, genetic-based, particles form-based algorithms.
Yes. Yes.
How are they different from this machine learning, sir? In kind of for the optimization problems we solve.
Yeah, in the case of evolutionary algorithms, we have one objective functions. So, like if you go for genetic algorithms, we have objective functions, and again, we are trying to achieve that with objective functions by different software and mutation. Uh, and in the case of so, what is the question? You want to
I wanted to know the difference, sir, like the evolutionary computing with
with machine learning?
optimization algorithms, so particles form optimization, and
Okay.
genetic
Yes, yes.
algorithms.
So, yeah, in that case, they are going to work on specific objectives, and probably they are doing a great job. And genetic algorithms have been also used for different types of learning for doing specific small problems. But from the data point of view, we are not going to give the input data and level and train them. Although they are able to go for exploration and exploitation type of things, finding out the different local minima, global minima, they are capable of doing that sort of things. There are a lot of different methods which are coming out in search spaces, and people are doing the genetic algorithms or evolutionary computing is also being used in the case of artificial intelligence. So, but the training data, we have the different algorithms where we have used genetic algorithms for learning as well. So I also have worked in the same way where we have given the data and we have tried to simulate the classifier, which is genetic learning.
No, I just want to know, can we call them machine learning, or is there any
Yeah,
different
yeah,
algorithm?
yeah. We can take them in the AI. We have the evolutionary part, and that is also part of machine learning.
Okay, okay,
Yes.
that's my doubt, whether
Yes, yes.
do they come under machine learning or not?
Yeah, yeah, that is a part of learning because we are able to learn with that algorithms also.
Okay, sir. Okay, sir. Thank you, sir.
Hello, any participants having any doubts?
Tools of AI, one particular person have asked, so it is not clear tools of AI. But if you go for the machine learning for clustering classification, there are a number of tools are available. Like we can go for Weka, Origin, Rapid Miner, then different scikit-learn, TensorFlow for deep learning, Keras, Thenos. A lot of libraries are available for doing different works. Yes. Yes, one question is there. AI in pharmaceuticals. Yes, AI is working very good in context of medical data science and pharmaceuticals also. We need to give the data. Mycin is one of the expert system which works on the medical diagnosis, and people are working. And if you provide the different medical pharmaceutical information, a lot of systems are available which are working with closely working with the AI or machine learning.
Sir, I
IBM
have one doubt, sir.
IBM Watson is also is able to suggest the information or suggestion to the nurses in USA and all. So they have database for the medical information. IBM Watson, yes,
Sir, I have one question, sir.
yes.
Sir, the AI is implemented in R Studio also. Which is better, sir, R Studio or Python?
Yeah, so if you see from the implementation point of view, if you are a very good coder, then you go for Python. And in current scenario, Python having lot of libraries for implementation of each machine learning algorithms. You will find open source libraries. Although in R also we have all the things, but Python is upgrading a fast in a for very rapid way in context of machine learning and deep learning library upgradation. We'll find all the different libraries of this machine learning, then new papers which are coming for the reinforcement learning and all in GitHub. And in R also we have all the things, but probably the new researchers are not moving into R. Most of them are not going for R. But you can work if you are not well efficient in the case of programming practices or coding, then R is good. And Python have more advanced and more, you can say, sophisticated libraries for work. So I suggest if you feel comfortable in coding, then you go for Python programming language.
Thank you, sir. Thank you so much.
Sir, somebody using MATLAB also, is it preferable, sir?
Yeah, if your institute have the license and you are capable to afford the MATLAB, then it is very good because MATLAB having a lot of libraries, and you can usually easily you can write the codes in few lines of code, and you can implement any deep learning model or any model. So latest version of MATLAB will provide you a lot of facilities.
Sir, could you please suggest me the references for use case of medical image processing, sir, for practice?
Okay, you can search my profile. I have we are working in the medical images, and you will find a lot of the medical image data set, which can be used for training and testing purpose, and for prediction also.
Thank you, sir.
Sir, can you say your website at ID or address to search that?
Uh, okay.
Or your
Can you please ping me in chat box?
If you search the different research papers, you will find probably if you are searching the different area in which you are working, and the research paper are give you the links of the different data sets which they have used in their paper. So that can be used. So I am sharing my link, my website link in the chat box. We are still in the stage of compilation of all the different links where we can compile and provide the information. I hope we have finished this part. If you have any doubt, you can mail me also. है ना?
Sir,
Yes.
thank you, sir.
Okay.
And you allocate some time in your busy schedule for deliver the topic about AI in this session, sir. Thank you, sir. And can you share your PPT to the participants, sir?
Yes, yes, I can share.
Okay, sir. After complete the session, you mail to me, sir, and
Yeah,
I
I will
will.
mail it to you, and then you
Yeah,
can share.
I will send that PPT to the participants, sir.
Okay, okay. Okay, thank you, Rao sir.
Thank you, sir. Thank you.
Thank you all for listening.
Okay, all the participants, I'll put that attendance link after complete the 2 sessions by 4 o'clock. I'll put the attendance link. Okay, I'll put that attendance link in chat box, and I'll put in WhatsApp group also. Okay, sir. All the participants, I'll close the session. Thank you.
Okay, sir. Thank you. Thank you.
Oh, right, right.
Excuse me, sir. I think I am not added in the WhatsApp group. Can you put the link of WhatsApp group here in this message or chat box?
Sir, attendance link, please.
Ma'am, they are sent the WhatsApp link in through email. Could you please check your email?
Okay, okay, I'll check. I'll check.
Excuse me, any organizer here?
I hope they are left.
I think they are not sent the attendance link still for morning session also.
I mean, they are going to send the attendance link for 2 sessions at a time.
In the afternoon, they will send.
Yeah, after end of the afternoon session, they are going to send the attendance link in chat box.
So timing for the next session is?
Sorry?
Timing for the next session is?
I hope I am also waiting for the timings of second session, but till now they didn't send in chat box. In WhatsApp also they didn't send.
I mean to say we can leave now.
Sorry?
We can leave now.
Let me check in WhatsApp there.
There is nothing like attendance on
Yeah,
the WhatsApp.
it's 2:30 p.m.
చూడండి మా ఇద్దరు